Hello, welcome back to Learning with Ms. H. Today we're going to go through dihybrid crosses. Hopefully by this time you've gone through the monohybrid crosses, which is the single trait crosses. You've done the 4-box Punnett squares, and you've gone through all of the vocabulary. So the first thing I'd like for you to do is go through these vocabulary words and see if you're able to define these on your own. So take a minute, pause the video, and try and define each of these terms. And then once you've done that, go ahead and come back. All right, welcome back. Hopefully you've got these defined. Homozygous means the alleles are the same. Heterozygous means they are different. That's what this triangle is. If it's dominant, it's going to show up. We're going to write it as a capital letter. Recessive, it means it's going to hide. You're only going to see it if you have 2 copies of it. Genotype, that's our genetic code. That's the letter combinations that we use. And then phenotype is the actual trait that we see expressed. So hopefully you guys got all of that and you are good on terminology. The next thing we're going to look at is a monohybrid cross with parents that are both heterozygous for a trait. Doesn't matter what it is right now. Remember that when we did this, you did the 4-patch Punnett square, and then you had the section on top and on the side that you filled in your characteristics. So it looked like this on the top and the side, and then when you fill it in, the side is moved across, and the top is drug down. So I've color-coded it here so you can see where all the letters came from. So these 2 capital A's came from the parent on top. These 2 capital A's came from the parent on the side. Same thing with these lowercase and these lowercase. Then in order to analyze this, you are going to count up your boxes and figure out your percentages and your ratios. So we have 1 that is homozygous dominant, 2 that are heterozygous, and 1 homozygous recessive. So our genotype is going to be 1 homozygous dominant, 1 homozygous recessive, 2 heterozygous. So writing it that way, it's 1, 1, 2. Generally, we go from the top left down, so we would write 1 to 2 to 1, kind of like a hopscotch. For phenotypes, remember we're looking at what is expressed. So for 3 of these boxes, we have capital A's, so the dominant characteristic is expressed. For 1 of them, it's 2 recessive, so we have the recessive characteristic expressed. So if we're looking at height, we would have 3 tall and 1 short. So that is our general quick review of Punnett squares. So the next thing we're going to look at is how we do this. For dihybrid crosses, we care about something called independent assortment. So that means that the alleles are going to separate on their own. They do not care what each other is doing. So mom's going to do what it does, dad's going to do what it does, and they don't care what the allele from the other parent is doing. So that is independent assortment. That is super important for this because it's going to help us with pairing up our alleles. So if you remember doing the FOIL process in math, first times first, outside, inside, last times last, we're going to do a similar thing here. We obviously don't have the full formulas, but we're going to do each of our letter A's will match up with each of our letter B's. So in order to do that, we're looking at 2 traits for a dihybrid cross, the A and the B. We're not going to worry about what the traits are for right now. We're going to just practice how you match these up. So capital A is going to come over here with capital B, and then your capital A is also going to come over and match with the lowercase b. So this A matches with each of the B's. Then we're going to come over to our second A, which is a lowercase a, that is also going to match with each B. So little a, big B, little a, little b. So what I would like for you to do is go ahead and take a minute here. Sorry about that. What I would like for you to do is go ahead and take a minute here and do some practice with these. I used some D's and some H's in here along with your A's and B's. So match up the D's and H's here, and then match up the A's and D's here. And we'll do those two examples. I'm going to give you some time here to get that done. Match it up just like we did here. And then pause the video while you're doing that. Once you're done, come back, restart the video, and we'll talk through what it should look like. We have this first capital D matches up with the first little h, and then it's going to match up with the second little h. So we have capital D, little h, capital D, little h. Then we have the second one down here, going to match up with each of our h's. So we have again big D, little h, big D, little h. So these are our 4 possible allele combinations for that parent. If we come down here to this one, we have little a, big D, little a, little d, and then down here, little a, big D, little a, little d. So those are our 4 combinations. If you need some more practice with this, go ahead and do these next 2 examples. Pause the video. I'm going to go ahead and write down the combinations you should get from this. So when you come back, you'll see the answers to be able to check your work. So go ahead and pause the video now, and I will write these while you're gone. Okay, so welcome back. Hopefully you have these combinations written down as your answers for these bottom 2. I put the little commas in between just so you can see where that separation is and where each pair is. When we are doing crosses with multiple traits, we are going to multiply by 4 each time we add a new trait. So we started off with 1 trait is 4 boxes. So 2 traits, 4 times 4 is 16. So we have 16 boxes in a dihybrid cross. For 3 traits, we're going to take 16 times 4. That gives us 64 boxes. That would be a trihybrid cross. There is a trick to doing trihybrid crosses. You're going to do the dihybrid just like normal. So if we pretend that that D is not there, we have capital A, capital B, capital A, little b, big B, little a, little b. So there's our dihybrid. In order to add the tri, we now have the D's to contend with. All you have to do is on each one of these allele pairs, it gets a big D and a little d, 1 for each. Big D, little d. Big D, little d. Big D, little d. So that means this then becomes A, B, big D, A, B, little d. And then this set of 3 is what will go in our box instead of a set of 2. If we wanted to add, for example, an E and make it 4 traits, we would then take this D and we would add these E's. Let's make it 2 capital E's, just so we have a little bit of a difference there. So now each of these D's gets an E on it. All the way down. So now we have A, B, D, E. We have the little A, B, D, E. So we have a big A, B, D, E here. We have a little A, B, D, E here. And we're going to do each of those twice in this case because we have two big E's and two big E's. So what we end up with here is big A, little b, big D, big E. Same thing again for those two E's. And then we have big A, little b, little d, big E. And you can continue doing this for as many letter combinations as you want to make. We could put an F or an L or a G or whatever we want after that. We can continue doing that for as many traits as we would like to. And that's the trick for doing 3 or more traits very quickly. That is the extra credit work. For right now, let's take a look at how to do this with a dihybrid cross with 16 boxes. So here's a cheat sheet. If you are in my class, I have a copy of this cheat sheet with the steps on it, along with pictures already posted on our class page for you. If you're not in our class, feel free to write this down. We are going to look at a dad that is homozygous dominant for trait A, homozygous recessive for trait B. So the first thing we need to do, step number 1, is determine our parent genotypes. So dad, let's be consistent with color, dad, homozygous dominant A, homozygous recessive B. So we have now determined the parent genotype for dad. For mom, she is heterozygous for both the A and the B. So heterozygous means one of each. So now we've determined both parent genotypes. We also determined that the ability to curl your tongue is the A. So tongue curling is dominant. So a capital A means you can curl your tongue. A lowercase means you cannot. So both of our parents are able to curl tongues because they both have capital A's. The thumb curve, so that is the hitchhiker's thumb. So you can see how my thumb kind of curves back here. The thumb curve is recessive. So if you have dominant, your thumb is going to be straight. So I don't know if I can even make mine do it straight like this. I have to like force it to do it. And if you are recessive, then you have the hitchhiker's thumb, you're able to curve it. And it will actually automatically curve and you're going to have a hard time straightening it out. Like I have to force it. Okay? So that's going to become important when we talk about phenotype, remember. But right now, we have our possible genotypes figured out. Now we have to assign our combinations. So we are going to FOIL this out. So dad has homozygous of each. So his is easy. He's capital A, little b for all 4 potential pairings because you have big A, little b, big A, little b, big A, little b, big A, little b. Okay? Mom is heterozygous for both, so hers is going to be a little bit more complicated. Big A, big B. Big A, little b. Little a, big B. Little a, little b. So those are moms for possible genotypes. I'm sorry my screen keeps going to sleep. I don't know why it's doing that with the camera going. The next thing we have to do is place the allele combinations on the table and keep them paired together. So we have to keep these paired up. So both of those letters will go in one spot together. Both of those letters go in one spot together. So we need to make sure we keep these paired up. So we'll have two in one spot. So the other thing I have for my students in my class is a pre-made dihybrid cross grid. I will try to put a link to these templates and helpful bits in the description. I'll try to remember to do that. But if you're in my class, these are posted on our class lesson page for the day. So you can get these, you can print this out and do it on paper. If you want to do it on the computer, you can type into it directly. You'll just have to make a copy of it for yourself. So on this, we're going to take parent 1 across the top, parent 2 down the side. Excuse me. For our purposes in our class, I do not care which parent goes where. When you get to college level, it may make a difference for your professors depending on how deeply involved they are in genetics. So let's remain consistent here. Let's put dad on the side so we don't have green on green. And we're going to do these 4 allele combinations. So remember, all 4 of his are the same. So they're going straight down the side. And then for mom, we'll put her across the top. And remember, in a dihybrid cross, you have 2 letters in each box. That means for a trihybrid cross, you would have a 3rd letter in each box. And then from here, we've placed our allele combinations and kept them paired up. And then we've got, we have to go in and complete the square now. So we're going to do this the same way we did for the mono crosses. We're going to pull down from the top, across from the side. When we do this, we need to make sure that we go in alphabetical order, and then capital always goes before lowercase. So you see I left some spaces here because we need to make sure that we go alphabetically and the capital comes first, so it ends up looking something like this. So I'm going to pull a couple of these down, and you'll notice how I do my spacing when I'm doing these so that there's room in between. If it's the second lowercase, it's always going to go towards the end, or the third, or whatever, however many you're working with. For this one, I'm going to leave room for lowercase behind and a capital in front, even if that's not what it's getting, because if it gets the same thing it's already got, it doesn't matter. So then we have, all right, so now I have finished up pulling down from the top, and now I'm going to go across from the side. I apologize for the background noise. We apparently have some heathens in the hallway. So you can see how quickly this goes. I'm actually taking a little bit more time just to make sure I have them all correct. But it does go very quickly once you get used to doing it. So there's our finished Punnett square. So we are all the way down here to step 4. So now we just have to do step 5, which is to analyze it like we normally would to figure out our genotypes and phenotypes for the ratios. So our genotype, remember, is our letter combination, and our phenotype is what it looks like. So we're going to go through and we're going to look at everything that has homozygous A, heterozygous B. We're going to do that first. So when you look through, the only 2 columns with homozygous A are these first 2, so we can ignore this half of the grid for now. For heterozygous B, it is only this first column. So for this one, homozygous A, heterozygous B, we have 4 boxes. We're doing ratios, so I'll always put the semicolon there. Now the next one, we have finished up this whole first row. So the next one we're going to look at is this. So we have homozygous A dominant, and we have a homozygous recessive B. And again, it's just this middle column here. So we have 4. Our third one, heterozygous for both. Again, it's the one column, so we have 4. And then our last one, heterozygous A, homozygous recessive B. Again, a full column, so 4. It's not always going to work out this way. It just depends on what the combinations are of the parents. When you have something like this, after you're done figuring out all the ratios, the next thing you're going to do is you are going to reduce. So all of these numbers are divisible by 4. So we're actually going to reduce. So our ratio is not 4 to 4 to 4 to 4. It's 1 to 1 to 1 to 1 because we divide it all by 4 to simplify and reduce it down. So this is our genotype ratio, our letter combinations. So the next thing we're going to do is our phenotype ratio. What does it look like? So we know that if it has a capital letter, it's going to show dominant. So we're going to look, are any of these going to show recessive for A? So hopefully you looked at these and figured out that none of these are homozygous recessive. So we're just going to make a quick note over here. All are going to show dominant A. Okay? And for this one, remember that our dominant A is the tongue curl. So this is A, that's B. So our dominant A is ability to curl the tongue. So they can curl. Okay, so everybody can curl. So then we need to look at our B's and remember that a dominant B is a straight thumb. So we need to look and see how many of them have dominant B's. So this column is all dominant B's. This is not. This one has dominant B's in it. This one doesn't. Remember, it only takes one capital letter to show the dominant trait. So our first set is going to be all of our capital A, capital B in any number. So our first phenotype, can curl straight thumb for our capital letters, okay? And we have 8 boxes. And we'll do our semicolon, and now we need to look at can curl bent thumb. Or curved thumb, whichever way you want to say it. So these guys all have 2 lowercase b's. So this is capital A, little b, and again that is 8 for these 2 columns. And then once again, each of these numbers is divisible by 8. So instead of 8 to 8, we have a 1-to-1 ratio. If it asks how many or percents, 50% can curl with a straight thumb, 50% can curl with a bent thumb. 25% will be each of these genetic genotypes. Okay, so the next thing I would like for you to do is to do one of these on your own. I'm going to give you a set of parents, and we're going to take a look at it really quick to see what you come up with. So I'm going to take out a clean sheet, and let's do parents again. We're going to give you parents that are both heterozygous for all traits. So let's do mom, heterozygous for both, dad, heterozygous for both. Okay? So again, you can fill in your steps here. We already did step 1 because I told you what they are. So go through all your steps, foil it out, fill in your grid. I'm going to come back at the end of this after you've had some time. Go ahead and pause the camera. Once you've had some time to do it, you can come back and I will have a completed grid to show you. If you would like to watch me fill in the grid, you can leave the camera running and try one by or the video running and try one by yourself. I'm going to do this very quickly, so it won't take more than probably about 30 seconds of your time. So when you come back from pausing, you won't have to fast forward at all. You can just watch me do it in those 30 seconds. So go ahead and head out, fill in your grid, and come back to see the analysis. Okay, so I'm just filling these in all the way across. And as you can see, it doesn't matter which parent goes in which spot. That's a little b. I love these erasable pens. It's the best invention ever. Okay. So I've got it all the way filled in and I'm ready to do the analysis. So it did not take long at all. So we're going to go genotype and phenotype. This is a true heterozygous dihybrid cross because both parents are heterozygous. So this has some standard ratios that you're going to see come out of this, and if you memorize these, you will never have to do this particular cross again. It's a very common one, so I highly recommend doing that. Hopefully you finished yours by now. So what we're going to look at here, we're going to look for boxes that are the same. So this is homozygous dominant for both. There's one. Then our next one, homozygous dominant A, heterozygous B. 2. Homozygous dominant A, homozygous recessive B, there's 1. Then we have heterozygous A, homozygous dominant B. There's 2. Then we have, let's do pink. We haven't done pink yet. Can you see pink? Yes. Heterozygous for both. There are 4. And then we have heterozygous A, homozygous recessive B. There are 2. And now we're going to start over with our colors down here. Homozygous recessive A, homozygous dominant B. There's 1. Homozygous recessive A, heterozygous B. There's 2. And then homozygous recessive for both. There's 1. So this is your genotypic ratio every time you do a true dihybrid cross where everything is heterozygous. 1 to 2 to 1 to 2 to 4 to 2 to 1 to 2 to 1. It's a little bit of a cadence. And it's the same backwards and forwards. It's a palindrome. 1 2 1 2 4. If you go from the back, it's 1 2 1 2 4. So it's the same backwards and forwards. So cool trick. If you memorize this, you never have to do this particular square again. For the phenotypes, for this, remember we're looking at what is expressed. So anything that has a capital A in it is going to express our phenotype, which was capital A means it can curl. So capital A equals can curl. Capital B means straight thumb. So I'm going to make a note of this off to the side so I remember that. So capital A's, I have this one, so the whole column, this whole column, and then I'm going to have these top 2 rows. Those all have capital A's. So we're ignoring these 4 boxes here. So our first phenotype is going to be it can curl, and then we want the ones that have straight thumbs, so capital B's. So this one, this one, this one, and this one, because those all have capital B's. This first one here, not this one, it's recessive. This one, not this one, it's recessive. All 3 of these have a dominant of each, not this one, it's recessive. So we're going to count the circles. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 can curl straight thumb. Then we're going to look at our recessives that we left. So 1, 2, 3. So we have 3 can curl bent thumb. Okay, so now we've finished all of these boxes. So now we're going to pay attention to these 4 that we ignored right here. So all of these are homozygous recessive for A. So it's a little a, which means it cannot curl. So our first phenotype is cannot curl, and then we want to stick with the straight thumb for our first one. So we're looking for a capital B. So we have one here, and one here. So we have 3 that cannot curl, straight thumb. So that is our third phenotype. And now you should notice the only one that is left is this guy here that's double homozygous recessive. So we now have one that cannot curl with a bent thumb or a curved thumb. So that is your analysis for the genotype and the phenotype. And again, this is a standard ratio. Anytime you do a true heterozygous dihybrid cross, every characteristic is heterozygous. If you memorize these ratios, 1 to 2 to 1 to 2 to 4 to 2 to 1 to 2 to 1, 9 to 3 to 3 to 1, you will never have to do this again. Okay. There's no simplification to do here because nothing is divisible by the same numbers because we have these ones in here already. So the next thing that we will do, I'm going to have you do a couple more examples. So let's have you do a homozygous recessive parent crossed with a homozygous dominant parent. And let's go ahead and do a homozygous recessive parent with, have we done a homozygous? We've done, let's do a heterozygous parent. We didn't do that, right? What was that? Nope, we didn't. All right, so let's do all heterozygous and all homozygous recessive. So go ahead and try to do these two on your own. See how it goes. If you have questions, feel free to put them down in the comments, and I will try to come on and answer the questions for you. And again, I will try to remember to put a link to these cheat sheets in the comments for you, so you can have a copy of the blank template, and you can have a copy of the digital version of the cheat sheet here. But hopefully that helped, and it gave you some of the theory behind how we do this. And then don't forget your little cheat sheet here for when you have 3 or more traits. Remember that 3 is going to start with 64 boxes, and then you will multiply times 4 each time. So 4 is going to be 256, and you'll continue going on from there. Once you get above 4, it becomes really impractical to do it on paper. But they're kind of fun. I enjoy these. I love genetics. This is one of my favorite things to do. So hopefully this was a help to you with figuring out how to do dihybrid and trihybrid crosses. Thank you. We'll see you next time. In the meantime, be safe, make good choices, and live your best life. We'll see you next time.